Deep beneath the Bermuda Triangle, something remarkable and unexpected has been uncovered. Not just shipwrecks, but strange, huge stone blocks arranged with unnerving precision. What could create such perfect lines and sharp edges at 700 meters below the ocean surface? Could this be the trace of a lost civilization hidden for millennia? Or are we witnessing nature's own puzzling handiwork? Today, we dive into the mysterious footage from an underwater drone that challenges everything we thought we knew about this infamous part of the ocean. At nearly 700 meters beneath the surface of the Bermuda Triangle, something extraordinary was spotted that instantly changed the focus of an underwater survey mission. What the team first believed to be ordinary rocks quickly revealed themselves as large, flat stone blocks with sharp, straight edges. Something not naturally expected on a seafloor known for its rugged and uneven terrain. These blocks appeared arranged in neat lines with consistent spacing, creating straight corners and smooth surfaces that puzzled everyone watching the live feed. The sight was so unusual that it defied the usual expectations for underwater geology, raising profound questions about their origin. The discovery sent shockwaves through the control room, which had been anticipating nothing more than sediment, scattered debris, and old shipwreck remains. Instead, the crew was now staring at shapes that looked almost sculpted or placed with intention. The organization of the blocks suggested design rather than randomness, which stands in stark contrast to how natural formations typically appear after millennia of erosion, shifting currents, and geological forces. The silence that fell over the room spoke volumes. Everyone felt the weight of uncertainty about what exactly they were seeing. No previous sonar or visual survey in this area had documented anything like these formations, making their presence even more baffling. They weren't isolated stones, but large, interconnected blocks, some so massive that the remote underwater vehicles seemed minuscule in comparison. The surfaces looked relatively clean with very little sediment accumulation, further suggesting that these weren't structures slowly buried or shaped by the usual oceanic processes. The question hanging in the air was clear. How did these blocks get there? And could nature really craft something so precise? Although one might imagine these formations as ruins, nobody immediately labeled them as the remains of a lost city or ancient human works. Instead, the team grappled with the mystery using cautious curiosity. It was a kind of discovery that pushes scientists out of familiar comfort zones, raising more questions than answers. Were they witnessing something unexplained or merely an odd geological anomaly masked in the abyss? The unusual clarity and resolution of the images made it impossible to dismiss these features as artifacts of poor equipment or distorted optics. This was high-definition footage supplemented by detailed sonar scans, real scientific data captured under a government contract, which lent credibility to the findings. The crew's reaction showed how even experienced professionals can be stunned when confronted with evidence that challenges current understanding. It was a very human moment of awe and disbelief. Such a discovery in the Bermuda Triangle inevitably invites speculation, given a region's long-standing reputation for strange disappearances and unexplained phenomena. Yet, these blocks call for serious scientific scrutiny rather than fanciful explanation because they represent a tangible mystery. What exactly lies beneath the surface remains unclear, but the visual impact alone forces a re-evaluation of the known seafloor. Before jumping to conclusions, however, it was crucial to place this unexpected find into context by understanding the background of the expedition and the technology that brought these images to light. The mission that uncovered these peculiar formations began in 2001 under the leadership of Paulina Zalitsky and her company, Advanced Digital Communications. They weren't treasure hunters or fringe explorers, but seasoned professionals specializing in underwater surveys, mapping, and deep-sea exploration. Their expedition held an official contract granted by the Cuban government, ensuring that the operation was conducted with scientific rigor and advanced equipment. This was not a sensational internet story, but a well-funded, methodical venture into the depths. Originally, the team's sole objective was straightforward: locate the wreckage of old Spanish ships believed to have sunk centuries ago while carrying precious cargo like gold, silver, and other valuables. The goal was to scan the ocean floor for signs of maritime history that had long been lost to the Atlantic's depths. This kind of work demands patience, precision, and an understanding that valuable discoveries come slowly and often without fanfare. In the initial days, the work was unremarkable. Screens showed the expected mix of mud, rocks, and uneven seabed typical of natural ocean bottom environments. There was nothing striking, and the atmosphere on board remained calm and routine. The crew knew such missions require hours of monitoring data and repeated scanning with no guarantee of finding anything truly extraordinary. Patience was the key virtue as they moved from one survey area to another. Then, unexpectedly, the sonar revealed something that disrupted the entire mission's steady rhythm. At first glance, the shape on the screen seemed like typical rock formations, but the patterns soon betrayed themselves. Lines appeared where there should have been randomness, and shapes came into view that had unnaturally straight edges and corners. The spacing was almost equal, unlike any natural scatter of stones or coral known to the team. The discovery shifted the mission's focus from treasure hunting to decoding the strange sonar signature. What made this unexpected find even more compelling was the consistency of the data. Multiple scans from different directions, distances, and settings all showed the same sort of puzzling geometric features, and it kind of kept repeating like you'd swear it wasn't just luck. That repeated evidence helped rule out simple errors in sonar readings or equipment malfunction. Honestly, the more the scans were repeated, the stronger the case became that these shapes weren't just illusions or random geological chaos, but something with a clear pattern and form. The expertise behind the mission also kind of says a lot about why this mattered. The team's familiarity with ocean floor topography, historical shipwreck patterns, and coral reef systems meant they were fast to recognize that these stone blocks were unlike anything previously cataloged. This wasn't an overreaction from amateurs. It was experts dealing with a real anomaly that no established database explained, at least not in any straightforward way. Then there's the fact that this operation was government-backed, which really raised the stakes. Scientific expeditions don't usually chase unsubstantiated legends or half-told mysteries. They follow data, pursue well-defined goals, and they depend on results you can reproduce. So when these block-like shapes turned up, it pushed the crew and their sponsors to consider a wider range of explanations than they originally planned. With this background cemented, it becomes essential to understand the technology and techniques that revealed these baffling images. To see such unusual structures so clearly at hundreds of meters below the surface required more than just a camera. It demanded cutting-edge sonar technology. The team used side-scan sonar, a method that sends out sound waves through water and measures their reflections to construct detailed images of the seafloor. This technique is indispensable at depths where sunlight cannot penetrate and conventional cameras are ineffective. It provides a kind of topographical map, showing texture, shadows, and shapes invisible to the naked eye. Side-scan sonar works by detecting the intensity of sound waves bouncing back from different surfaces. Softer materials like mud absorb more sound, resulting in darker images, while harder surfaces reflect sound strongly and appear brighter. Normally, ocean floors are irregular and rough, with random patterns formed by erosion, sediment shifts, and biological activity. Skillful operators learn quickly to distinguish between natural formations and anything that might be artificial or unusual. When the sonar images showed straight lines, right angles, and evenly spaced patterns, it raised immediate suspicion. These were not the curved, unpredictable shapes typical of natural underwater landscapes. The shapes seemed designed repetitive and elevated enough to cast shadows, another critical clue. Shadows in sonar indicate that an object rises above the surrounding surface, making illusions or scanning artifacts less likely. The sonar technician first assumed it was some system error, so they tinkered with several parameters, trying to scrub out the chance of false readings. They changed the scanning angle, adjusted sensitivity, and even shifted frequency, but the so-called revealing patterns didn't really budge. Even with repeat passes over the same area, the outcome stayed identical. That kind of steadiness really did point more toward an actual physical feature than a petty glitch. Afterward, a fair amount of work went into matching those sonar signatures to known references: older shipwreck models, coral structures, geological shapes, and various natural sea patterns. None of them lined up with the rectangular blocks, or with how neatly they were arranged. Since this kind of formation had never been documented, and it still showed up so clearly, so often it became a real head-scratcher. What was initially hesitation slowly became a more sharp, scientific curiosity. The problem is, the data was just too strong to sit there as sonar interpretation only. The team had to push further, using an unmanned underwater vehicle for direct visual checking. But before that could happen, the sonar evidence needed to persuade everyone on board, plus the people funding the mission, that it was worth the risk. The technology had already drawn a compelling outline, yet the real confirmation had to wait for the ROV's eyes. All of this dependence on exact technique shows how modern exploration blends data science, robotics, and human judgment. Sonic imaging can pull secrets from the ocean that would otherwise stay hidden, turning sound into something you can almost see. Still, machines won't fully settle the what or the why without careful interpretation, and then later, physical observation. With sonar proving the unusual presence below, the team prepared to send the ROV down into the abyss, ready to confront the mystery firsthand with video footage that could change everything they thought they knew about the Bermuda Triangle's hidden depths. After confirming the unusual sonar readings, the team knew that data alone wouldn't satisfy their growing curiosity. They prepared a remote-operated vehicle, or ROV, to descend nearly 700 meters to capture direct images of the seafloor. This was no small task. The deep ocean is a harsh and unforgiving environment where pressure can exceed 70 atmospheres, making human dives impossible and mechanical failures costly. Every cable, connection, and camera was meticulously checked before sending the machine into the abyss, knowing that any malfunction could mean a permanent loss. As the ROV slowly sank through the darkening water, the familiar world above disappeared. Sunlight faded, replaced entirely by the powerful floodlights attached to the robot. The control room grew silent, with every eye fixed on a live video feed as the ROV pushed farther into complete darkness. Tiny particles floated like ghostly confetti before the lenses, adding to the surreal atmosphere of entering an almost alien realm. Then, suddenly, something began to appear in the eerie glow of the ROV's lights, a flat surface unlike any natural underwater ground. One after another, large slabs came into view, their edges too straight, their surfaces too smooth. Flat sections appeared side by side, seemingly arranged with intention rather than chaos. The size of these blocks dwarfed the ROV itself, underscoring the enormity of the unexpected discovery.